discussing wave optics, and in this we are discussing the subtopic principle of superposition. Okay, let me actually explain you कि सुपरपोजिशन होता क्या है. जब एक से ज्यादा वेव्स when they actually travel through a medium simultaneously, okay, then each wave travels independently of the other, as if the other waves were absent. An important part of this independent behavior of the waves is that the effect of all these waves get added together, So the resultant wave is obtained by the principle of superposition wave. Okay. So how do we really say? Suppose हम एक wave ले लेते हैं. Let's say एक wave है and its equation is y1. Okay. We represent this equation as y1, and then we also take another wave and we represent this as y2, and so on. Finally we take nth wave. Suppose n waves are there, so their displacement vectors are y1, y2, y3. क्या हैं इनके? We will call them displacement vectors. Understand? Okay. Because जब भी कोई वेव होएगी तो पार्टिकल क्या होंगे? They will vibrate up and down. So we will actually give or represent the wave in terms of their displacement vector. All right. Now, let us understand it through one pictorial representation. Exactly दो वेव सुपरपोज करेंगे तो रिजल्टेंट वेव क्या होगा? Let me just take you to this. Let me just draw a vertical line. All right, and we draw one horizontal line, and then let us draw yet another horizontal line, and one more line. Now let us take the first जो वेव है आपकी, यहां से ले लेते हैं हम. Let me take, this is your +2 and this is here is -2, and then +2 and then -2, +2 and -2. Let us take the first wave as like this. Okay, and the second wave ऑल्सो सिमिलर हम यहाँ पे एक वर्टिकल लाइन ऐसे डाल देते हैं जस्ट टू सी कि हमारी सिमेट्री मेंटेन रहे. Okay, and the another wave is also like this. So what is the resultant? This is wave 1. So we call it first wave. First wave, and this could be said as second wave. And if these two waves are superposed, then what will happen? आप लोगों की फिर से ये वीडियो ऑफ हो गए, प्लीज स्विच ऑन. It is important that you are engaged and you are actually in touch with me, whatever we are discussing. So I have explained you first wave as well as second wave. Now, if I have to join the two and if I superpose the two, can you tell me what will be my new wave? Here, this point is +2, this point is also +2, and they are in the same phase, yes or no? So what will be the amplitude of the third wave which is resulting out of these two waves superposition? आयन बताएंगे.
+4 हो जाएगा.
+4 हो जाएगा. So we will take +4 here. So this will be the beginning of my wave. So it will come here like this. Again, this is also -2 and -2. So what will be the amplitude of the new wave? सिंस -2 है सो आउटकम क्या होगा क्षितिजा? आपका ये आवाज नहीं आ रही है.
हाँ जी सर.
हाँ, व्हाट इज द फाइनल एम्पलीट्यूड हियर एट द पोजीशन, लेट्स से दिस इज ए बी. सो जब दोनों को सुपरपोज किया तो व्हाट विल बी द रिजल्टेंट आउटपुट?
सर -2 बोला था तो -4 हो जाएगा.
-4 हो जाएगा. वेरी गुड. सो यहाँ पे हम -4 इस टाइप से इसको दिखाएंगे. फिर ऑब्वियसली वापस यहीं पे चले जाएंगे. 0 + 0 विल बी 0, और यहाँ भी आपका +2 है तो ये भी +2 तक यहाँ ऐसे आ जाएगा. सो डिड यू अंडरस्टैंड द कॉन्सेप्ट ऑफ सुपरपोजिशन? यस और नो? एम्पलीट्यूड विल बी वेक्टोरियली एडेड. ओके. Now let us understand we will now discuss condition for constructive and destructive interference. Now as you know, थोड़ा सा हम इसमें और डिस्कस कर लेते हैं. If these waves are meeting at opposite phase, you know, so what will be the resultant amplitude? Ayun, can you guess? 0. Opposite phase होएगा तो amplitude 0 हो जाएगा. Okay, and same phase में मिलेंगे तो amplitude maximum हो जाएगा, right? ठीक है कि नहीं? So this gives us a new thinking that what is called is interference of two waves. Okay, in this interference we either whenever there is when the two waves meet in the same phase and their amplitude will be added. Okay, and at the same time if they are meeting in opposite phase their amplitude would be negated. Okay, So that is how it will give birth to interference. So what do you, let us understand what are the construction condition for constructive as well as destructive interference. Destructive interference occurs when two waves meet in opposite phase, and constructive interference happens when two waves meet in the same phase. Now let us take that we have two sources. Now we are discussing conditions for constructive and destructive interference. Okay. For that we should have at least two waves. Now let us take the two waves as y1 equal to a1 sine omega t and y2 equal to a2 sine omega t plus phi, where phi is the constant phase difference between the two waves. यहाँ पे लिख लेते हैं, phi is the constant phase difference between the two waves. All right. Now, since we are supposed to use superposition principle, that means the two waves are superposed and the resulting amplitude y would be y1 plus y2. So let us just add them, a1 sine omega t plus a2 sine omega t plus phi. Now let us further solve this mathematically. So what shall we get? We will get a1 sine omega t, and here we will get a2, and inside we will be able to write sine omega t cos phi plus cos omega t sin phi. Clear? Yes or no? समझ आ गया? So further I would be able to write this whole thing y as a1 plus a2 cos phi into sine omega t plus I would be able to write a2 sine phi cos omega t, sine phi cos omega t. Now what shall we do? Let us understand that we would write, let a1 plus a2 cos phi is capital A sin theta, and we would write a2 sin phi as capital A, rather इसको sin theta के बजाय cos theta लिख दीजिए, cos theta, and here A sin theta, ऐसा लिखिए इनको, one relation and two relation. So what will be my y? Let us see, y is equal to A cos theta sin omega t plus A sin theta cos omega t. Is this clearly understood, these steps, Ayon and Kshitija?
हाँ जी सर, समझ आ गया।
Okay, great. All right, let us now write it y as A cos theta sin omega t would become sin omega t plus theta. Now this gives me a reasonable understanding that after superposition, my resulting wave is also a similar type of wave with the same frequency, but with a different phase difference, which I say theta. Okay. So let us understand how do I really find my parameters. So if I do a square cos square theta plus a square sin square theta equal to a1 plus a2 cos theta, rather cos phi here, because that's the value, का whole square plus a2 square sin square phi. Alright, so we will have a square sin square theta plus cos square theta equal to a1 plus a2. इसको खोल दें थोड़ा सा, तो we will get a, here we will get a1 square a2 square cos square phi plus 2a1 a2 cos phi and plus a2 square sin square phi. Okay, so we'll get a square as a1 square plus a2 square sin square phi plus cos square phi plus 2a1 a2 cos phi. Got it? Then we can write the same thing as a1 square plus a2 square plus 2a1 a2 cos phi. So a will be under root a1 square a2 square 2a1 a2 cos phi. So you see, I got the amplitude of the resulting wave after superposition. Okay, and if I have to actually write in the format of intensity, then remember, intensity of a wave, intensity of a wave is proportional to its amplitude का square. You can say amplitude का square, or we can say intensity is I is proportional to amplitude a square, which means I can easily write I is equal to ka square, where k is a constant. Okay. Similarly, for individual waves, I can write them I1 as k times a1 square and I2 can be k times a2 square. Okay. So let us write down the final this thing. If I multiply this whole thing a square expression, what would I get here? Let us multiply by k. So what it will be? K times a square equal to k times a1 square, k times a2 square plus 2 a1 a2, rather k भी यहाँ पे डाल देते हैं cos phi. Understand? Any problem with this step? So I would write here I equal to I1 plus I2 plus I can write twice under root k a1 under root k a2 and cos phi. Clear? So I would be able to write this whole expression as I equal to I1 plus I2 plus twice under root, I can put I1 I2 all together, even you can write separate also, and you put here cos phi. Okay, so this is how we can write the final expression for intensity. Getting my point till here? So this is my expression for intensity. Now what is this you can easily see this terminology, which is actually this. There is this third term, 2 under root I1 I2 cos phi, which is called as interference term. Called as interference term. Okay. Now let us understand after this when would the constructive interference occur. Let us discuss about constructive interference. So what exactly we are looking for constructive interference? We are looking that cos phi must have maximum value, let's say 1. Or we can say phi की value क्या हो सकती है? It can be 0, it can be 2 pi, 4 pi and so on. Okay? Or we can say it is 2n pi. Alright? And phi is what? It is the phase difference. And what is the phase difference? Phase difference is, let us say 2 pi, okay, and the corresponding phase difference of 2 pi, what is the corresponding phase difference? It is 2 pi corresponds to how much? Lambda as a path difference. Path difference. Here 2 pi is the phase. Okay? Which means that means we can write it lambda corresponds to 2 pi as phase difference. So unit would corresponds to 2 pi upon lambda, and if P is the path difference, then P would corresponds to 2 pi P upon lambda, where P is arbitrary path difference. Path difference. तो ये वैल्यू आएगी मेरी, isn't it? So what would be P? So possibly what we can write is that 2 pi P upon lambda would have to be 0, 2 pi, 4 pi and so on for constructive interference. Correspondingly, what will be the value of P? So P can be, you can write, or P can be 0, okay, or lambda, or 2 lambda, or 3 lambda and so on, and finally it can be n lambda. Okay, so what is it that we are talking about? That resultant intensity at a point is maximum when the phase difference between the two superposing waves is an even multiple of pi, okay, or path difference is an integral multiple of wavelength. Is that correctly understood? Yes or no? Okay. So this is what is called constructive interference, condition for constructive interference. Now let us talk about, we can talk about destructive interference. So let us just learn about destructive interference. So when would this occur? When the value earlier this value of cos phi so we are talking about destructive interference. Let us now say what should be my cos phi. So the resultant intensity at P will be minimum. The resultant intensity at P, or rather resultant intensity at a point would be minimum when cos phi की जो वैल्यू है क्या होगी, -1. That will be the situation, because we had learned a square was a1, or rather इंटेंसिटी की बात कर रहे हैं तो I was I1 plus I2 plus 2 under root I1 I2 cos phi. So cos phi नेगेटिव हो जाएगा तो ये क्या हो जाएगा, I1 plus I2 -2 under root I1 I2, which is actually under root I1 minus under root I2 whole square. So you can easily see if I, मान लो दोनों इंटेंसिटी इक्वल हैं, I1 इक्वल टू I2 इक्वल टू I, then what will be minima? It will be 0. Understand? So destructive interference में it can become the minimum or even 0. So let us understand when does it happen. So obviously when my cos phi is 1, then what is the condition? It should be 2 pi by lambda multiplied by path difference is P, should be equal to what all? It has to be pi, 3 pi, 5 pi and so on. So it is odd multiples of pi. So what is my value of P? P would be lambda by 2, 3 lambda by 2, 5 lambda by 2 and so on. और जनरल वैल्यू क्या आ जाएगी, 2n minus 1 lambda by 2. So this is when I will get my destructive interference. Okay, so the resultant intensity at these points would be minimum when the phase difference between the two superposing waves is an odd multiple of pi, or the path difference is an odd multiple of lambda by 2. Okay, so tell me, have you understood this concept? Yes or no? Mr. Ion? Okay, क्षितिजा को समझ में आ गया? हाँ जी, Ion? Okay, so all right.